Remember when I told you no matter where I go, I'll never leave your side, you will never be alone. Even when we go through changes.
Now we are down to our fifth topic, mixing and flocculation. Let's start this with the mixing. Dispersing coagulants into the water is a critical step in the treatment process sequence. Mixing of chemicals may be accomplished by turbine and propeller mechanical mixers, over and under baffling inline mechanical mixers, inline static mixers, and by injection into the suction intake of the pump. For our velocity gradient is one of the main parameters used in designing mixing system and is determined using the following equation. Rg, or the velocity gradient, is equal to the power imparted to the water per unit volume over absolute viscosity of water raised to 0.5, which is also equal to the power imparted to the water over the absolute viscosity of water times the volume of the basin raised to 0.5. We have here the rapid mix design. Determine the dimension of the rapid mixing basin to process 3.0 mgd of water. The basin will be squared and the depth is assumed to be 1.5 times the width. Use a detention time of 30 seconds and the velocity gradient of 750 fps over per feet. The average minimum sustained temperature is 40 degrees Fahrenheit. The absolute viscosity is 3.229 times 10 raised to negative 5 pounds times second per feet squared. Two rapid mixing basins will be constructed, each having the capacity to process the entire flow. Determine the following. So for first part or solution part A, we are asked to determine the dimension of L, W, and D in feet. So here is solution part A. To calculate the volume of the rapid mixing basin by rearranging the detention time equation. As we know, detention time is equal to the volume of tank over the volumetric flow rate. But in this problem, we have to rearrange it so that it will be volume of the tank is equal to the detention time times the volumetric flow rate, as you can see there. So, kung lang nato i-plug in lang nato ang value. So, ang ato ang detention time is 30 s. Tapos, ibutan lang po nato ang atong Q, volumetric flow rate. Kana siya. Tapos, ibang butan ng mga conversion factor dira para ang mabili na lang is naka-fit na lang siya. Kay fit man natong kailangan. So, mato ang day, 24 hours, and then 1 hour is 3,600 seconds, and so on and so forth. So, ang indicate diri is, ang volumetric flow, volume sa tank nato is 139 cubic feet. So, now, ang volume sa tank is equal to the length times width times depth, which is equal to 139 cubic feet. Tapos, ginaingon man diri, since square man siya, so length is equal to width. So, ang ibig sabihin, same lang atong width o length. So, ang magawas is, ang volume, di ba, ang katong volume sa atong mahimo na siyang, instead of length times width, mahimo na siyang width times width, times, di ba, naka-indicate ganyan dito na ang width nato is, same siya sa length. So, same na sila WW times, ang katong depth nato is 1.5 times the width, kanina naka-indicate dira. So, mahimo na siyang, instead of putting length times width times depth, ang mangyari is W times W times 1.5 times W. Kaya ang 1.5 times W siya na tong depth. Kaya since naka-indicate man sa problem nato, is equal to 139 cubic feet. Tapos ang goal nato diri is makuha nato si width og si D og si L. So since same man si L og si width, si length og si width, pwede nato kuhaan si width og si na lang og si depth. So starting with our with width is equal to, ato lang ni isolve ng W times 1.5. W is equal to 139 cubic feet. Tapos, para makuha na to si width. So, width is equal to cube root of 139 cubic feet over 1.5. And that is 4.50 feet. Since same na itong width o length, so same na sila. So, check na natin width and length. So, now, ang kulang na lang is si depth. Si depth na to, diba nakabutang dito nga ang depth daw kay 1.5 times nimo sa width mo na siya ang depth sa ato ang i-design. So now, ang ato ang width, nakita naman nato which is 4.50. Bali, i-times lang nato siya dito sa 1.5. Tapos, karon na natay depth. So, ang atong width, so, man to answer, width and length is 4.50, while ang depth nato is 6.75 feet. Naka-fit sila tanan. So, that's it. For our part 2, so second, no, ang power input. Sa ato ang solution part B, katong gipangutan nga power input, makalculator siya through rearranging katong equation na akong gidiscuss a while ago, which is kani siya, rearrange lang na nimo para ma-solve ni siya nga problem. So, P is equal to G squared times mu times the volume of the tank. So, getting all the kanang mga required na mga given dito ibutang nato siya, plug in lang nato siya diri nga formula to sa rearrange nato. Di mo na siya ang answer itong 4.5. So, isolve lang nato ang G2, ang G squared, ang G, di ba na-discuss na ganina nga, ang G is, to siya ang velocity gradient. So, i-squared lang nimo siya pag abot din na problem, tapos i-times nimo ang mu, i-times nimo ang katong tong absolute viscosity of the water, mo na siya ang mu na to. I-times nimo ang volume of the tank. So, mo na siya ang ato ang velocity gradient. Kaning G na to is 750 s negative 1 squared na to siya. Tapos, ang ato ang viscosity, absolute viscosity na to, kaning nasa tunga, 3.229 times 10 raised to negative 5. No? Tapos, ang atong volume of the tank, which is na-solve na to ganina, which is 4.5 feet times 4.5 feet times ang atong depth. Bali, length times width times depth. So, mo na siya. Tapos, isolve lang nato na siya. So, yung siya 2.48 times 10 raised to 3. So, times nato siya sa, 550 pounds. And that's equal to 4.5 HP. Therefore, construct two rapid mixing basins with dimension of 4.5 feet by 4.5 feet by 6.75 feet depth. Each basin would provide with a nominal 4.5 HP mixer. The actual horsepower would be greater than this and would be estimated by dividing 4.5 HP by the combining efficiency of the mixer and the motor. So, muna itong answer sa power input. Flocculation. Flocculation is a unit process involving the slow steering and gentle agitation to promote agglomeration of the destabilized particles from coagulation into heavy, rapidly settling flux. So we have here primary types of device use and water treatment. So the first one is the horizontal paddle wheel flocculators, and the second one is the vertical shaft flocculator. Paddle wheel flocculator is calculated using the following equation. Power dissipated in the water is equal to the coefficient of drag equal to 1.8 for the flat blades, which is dimensionless, times area of the paddles, times density of the water, times velocity of the paddle relative to water, all over 2. Normally, VR is 0.70 to 0.80 of the paddle velocity. The velocity of the paddle blade is calculated from the following equation. So, velocity of the paddle blade, or VP, is equal to 2 times pi times distance from the center of the shaft to the center of the blade times rotational speed or revolutions per seconds. For our paddle wheel flocculation basin design, a flocculator that is 30 meters long, 15 meters wide, and 5 meters depth houses 4 horizontal paddle wheels. Each paddle wheels has 4 symmetrical arms with fiberglass boards, 2.0 meters from the shaft to the center of the board, rotating at 1.5 RPM. Paddles are 13 meters long and 0.20 meters wide. The water treatment plant processes 95,000 meter cube per diameter of water. Assume that the mean water velocity is 25% of the paddle velocity, and the CD equals 1.5, and mu and density are equal to 1.139 times 10 raised to negative 3 kg per meter seconds, and 991.1 kg cubic meter, respectively. Determine the following. So, first na itong pangitaon is with the velocity of paddle blades. So, muna siya ang pagpangita sa velocity of paddle blade. So, VP is equal to 2 times pi times R times N. If we recall, no, ang VP nato is equal to 2 times pi times R times N, where VP is the velocity of paddle blades, R is the distance from the center of the shaft to the center of the blade, and our N is the rotational speed or revolutions per seconds. So, kung nato itong given nato, din ipag nato diri nga equation. So, ang R nato is equal to 2, tapos atong N, kay 1.5 rev per minute. Tapos, kailangan man daw meter per seconds. So, ang final nga velocity of paddle blade. So, i-convert, maganda conversion factor para ang minutes may mga seconds. So, now, may mo siyang 2 times pi times 2.0 meters times 1.5 rev over per minute. Tapos, natin conversion factor 1 minute per seconds, 60 seconds. Over 60 seconds. So, pag solve na to, times na to siya and all, that's 0.31 meter per second. So, muna siya itong velocity of paddle blades. For our part B, the total power input, ang atong first buhatan is to find parts. First, find VR and A, which is very important sa pag-solve nato sa to ang total power input, no, which is P. So here, first solve for VR, which is 1 minus 0.25 V subscript P is equal to 0.75 times 0.31 meter per second is equal to 0.23 meter per second. So, nakuha na nato itong VR. So, magamit nato later. For our A is equal to 4 paddle wheels, 4 arms, 13 meters, 0.20 meters, and that is equal to 41.6 meters squared. Tapos, kaya i-plug in na nato ang mga values nato, ang C, subscript D, ang A, ang density, ang V, subscript R, cube, naka-cube itong itong VR, over 2. So, P is equal to 1.5 times 41.6 meters squared times 999.1 kilograms per meter cube times 0.23 meters per second. Tapos, A cube na to siya, raised to 3, over, all over 2. That's equal to 375 kilograms per meter squared per cubic seconds. Since naka-indicate dito ang kailangan ay unit niya at the end is W, so kailangan nato siya i-convert, no? So, ngayon, ang 379, i-convert lang, again nato siya convert. So, muna yung pagka-convert, tapos matud sa maabot siya 379 W. So, muna siya. Our solution part C, which is to find the velocity gradient, is equal to the power impacted to water per unit volume, represented by W, over the absolute viscosity of water, represented by mu, raised to 0.5, which is also equal to the power impacted of water, to the water, represented by P, over the absolute viscosity of water, represented by mu, times the volume of the basin, which is represented by the V. And this is raised to 0.5. So here, what we're going to use is the P over mu times V, or the power impacted to water over the volume of the basin times the absolute viscosity of water. So we already know the power impacted to water, which is 375 N times N per seconds. That's over our mu. This is our mu, 1.139 times 10 raised to negative 3, and must be multiplied to our volume of the basin, which is the product of 30, 15, and 5. Solving everything inside the parentheses and raising it to 0.5 will give us 12.2 seconds seconds raised to negative 1. That's it for our velocity gradient. For our detention time, we just need to, since it is noted there that it should be in minutes, that's why we have this conversion factor beside our original equation and the given. So we have here the volume over our volumetric flow rate, which is 95,000 meter cube per diameter, and the volume is 30 times 15 times 5. Just multiply it, divide it by our volumetric flow rate, then use the conversion factor beside it, and that will give us 34 minutes. That's it for our solution part D. For our solution part E, we are asked to find G times T, our velocity gradient times the detention time. And that is 12.2 s raised to negative 1 times 34 minutes times our conversion factor of 60 seconds per minute, and that is 2.49 times 10 raised to 4.
Vertical shaft turbine flocculator. In the new water treatment plants and those that use direct filtration, vertical shaft turbine flocculators are typically used. This type of flocculator has an impeller attached to a vertical shaft that is rotated by an electrical motor. So, important design parameter for this type of flocculator includes power number, effective tank diameter, and diameter of the effective tank diameter ratio.
The power number is calculated using the following equation. Power number, which is dimensionless, is equal to the power input over fluid density times rotational speed raised to 3 times impeller diameter raised to 5. For the effective tank diameter is determined from the following equation. Effective tank diameter is equal to the square root of 4 times plan of the area compartment over pi.